mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen. It's only the third time that we've actually detected an object that has come from beyond our solar system.
Interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond.
High above Earth's restless clouds, something cold and ancient travels across our solar system. Emerging from the spaces between the stars, an object, unconnected to the Sun's family, has crossed our cosmic threshold. Named 3I Atlas, it is only the third interstellar object ever detected making such a passage near the Sun, and already the questions it raises set scientific circles abuzz. 3I/ATLAS is far from an ordinary celestial wanderer. Its place of origin lies outside the familiar frontier, beyond the planetary nursery that gave birth to Earth, Jupiter, and all the other members of the Sun's retinue. It is a true emigrant, shaped by the forces of an unknown star system, now temporarily illuminated by the distant light of our own star. On July 1st, astronomers recorded 3I Atlas hurtling toward the Sun. Its trajectory unlike any local comet, its speed outpacing typical solar system bodies. Such a trajectory marks it as an interstellar visitor, here not to stay, but to pass through on a hyperbolic path that ensures it will, in time, leave us behind forever. Its closest approach to Earth will remain at a safe distance, at least 1.6 astronomical units away, meaning it will not pose a threat to life on our planet. Scientists pointed their most sensitive instruments at this cosmic traveler, particularly the James Webb Space Telescope, JWST. JWST's unparalleled vision soon revealed 3I Atlas to be a vessel of remarkable complexity, hosting a chemical archive from a part of the galaxy far beyond our usual reach. Its icy nucleus and streaming tail, detectable even from afar, present a unique opportunity to observe materials that have journeyed for millennia through the galaxy's darkness. A unique intruder. What distinguishes 3I Atlas is not merely its interstellar trajectory. Even in the earliest observations, astronomers noted its visible tail growing as the object advanced through our solar system, captured in vivid detail by Earth and space-based observatories. This tail, streaming with gas and dust, shows a story in real time, the result of sunlight, warming ancient ice, and releasing hidden materials. The images themselves are a demonstration of change in action, an unfolding transformation as our star's heat touches a visitor forged in another world. Continued observation by JWST added unexpected richness to the portrait. Its spectrometers detected water ice and vapor. No surprise for a comet, but no less valuable for their clarity. Alongside this water appeared carbon monoxide, a molecule resilient only in extremely cold, ancient environments, and carbonyl sulfide, a sulfurous species sometimes linked to tectonic or even biological processes on Earth. Each molecule provides context, but also deepens the mystery. These compounds are not unique to 3I Atlas, nor do they inherently indicate anything more than a long and cold past. However, when such molecules are discovered within an object not of solar system origin, they prompt comparisons with both familiar and alien chemistry. JWST's instruments also mapped the thermal profile of 3I Atlas. Here, scientists discovered something that invited further investigation: a thermal pulse at the core of the comet, a repeated centralized development of heat. not easily explained by current comet models. The Enigma of the Pulse. Typically, comets reveal their activity through tangled patterns of heating and outgassing, dictated largely by incursions of solar warmth. As sunlight strikes the surface, ice converts rapidly into vapor, jets erupt, and localized heating occurs wherever gas manages to escape. The overall pattern is chaotic rather than orderly, a jumble mapped by random fissures and uneven solar exposure. But 3I Atlas shows a departure from this norm. According to JWST's thermal maps, the comet's core is the site of a pattern. Heat emerges not randomly, but in a pulse, rising and fading with regularity at the center, rather than along the sunlit regions alone. What could cause this? Known cometary physics struggles to explain such centralized rhythmic energy fluctuations, especially at a point where sunlight is not yet the dominant factor. Periodic heating can sometimes be attributed to volatile materials trapped in pockets beneath a surface. As they thaw, these pockets might release gases in cycles, yet typically this process produces irregular bursts, not a consistent, repeating core pulse. To test the pulse, astronomers cross-checked JWST observations against multiple wavelengths and different epochs. The pattern persisted. Instrumental error seems unlikely. The measurements have been corroborated independently. Yet, there are no signs of comet rotation, visible jets, or obvious outgassing activity that could account for such a centralized rhythmic signature. A deliberate mystery. It is natural for scientists, and for the public, to wonder about extraordinary explanations. Throughout history, the line between natural and artificial, between routine physics and the seeds of life, has fascinated all who gaze up at the night sky. The suggestion that this pulse is alive, or that it is deliberately generated by a machine or alien intelligence, remains unsubstantiated by the data presented so far. Notably, agencies like NASA have responded directly to public speculation, emphasizing a stance grounded in evidence. They confirm that all available data are consistent with 3I Atlas being a comet, albeit one with unexpected thermal properties. There is no credible evidence to suggest it is artificial in origin or that it poses any risk to Earth or to other solar system bodies. The presence of a rhythmic heat signal, while intriguing, is not in itself a hallmark of life, nor necessarily of complex chemistry. With our current understanding, it remains a puzzle to be solved, not a declaration of discovery. Chemistry at the Brink. JWST's identification of water, carbon monoxide, and carbonyl sulfide compounds adds another layer to the story. Each molecule tells of the comet's place of origin and the physical processes that shaped it before its journey through interstellar space. Water ice is a foundational ingredient of many comets and is common throughout the outer solar system and beyond. Its survival on 3I Atlas hints at a cold, sheltered history, likely deep within another planetary system's distant reaches. Carbon monoxide, in contrast, only clings to existence in the coldest regions. Its presence, coexisting with water vapor as both are released, points to a remarkably pristine and ancient core, offering a truly unaltered sample of conditions from another star's environment. Carbonyl sulfide is somewhat rarer, and on Earth it appears both from geological processes and in environments shaping the earliest stages of biology. Its detection on 3I Atlas stirs curiosity about what chemical interplay is possible in interstellar space. However, While carbonyl sulfide may participate in interesting chemistry, it alone does not imply the presence of biological or artificially organized processes. The precise proportions and isotopic signatures of these molecules, once more data is gathered, may tell us more about the comet's birthplace. They could reveal whether the comet's chemistry has changed during its long journey, or if it retains the fingerprints of its home star. The science of caution. All discoveries about 3I Atlas are filtered through the rigorous lens of the scientific method. In the face of limited and sometimes ambiguous data, astronomers and planetary scientists must protect against the temptation to jump to conclusions. The term alive carries enormous scientific and philosophical weight and must be reserved for processes that meet a strict set of criteria. Comet 3I Atlas observed thermal pulse, while mysterious, is not outside the realm of possible natural phenomena, especially given our relatively recent and limited experience with objects from beyond the solar system. It could represent geologic processes unique to its star of origin, unusual layering and structural effects from its formation, or even novel outgassing patterns not yet observed in local comets. The known chemistry of 3I Atlas, water, carbon monoxide, and carbonyl sulfide provides more insight into material makeup than into function. No compound alone indicates life or engineering, and at present, the data resist any conclusion beyond the cometary, interstellar nature of this object. Interstellar Rarities. The history of observed interstellar objects is still in its infancy. Before 3I Atlas, only two others were ever documented traversing our solar system: Oumuamua and Borisov. Oumuamua, detected in 2017, became famous not only for its peculiar, elongated shape and lack of a cometary tail, but also for its anomalous acceleration. Debate raged over whether this could have been caused by natural outgassing, light pressure, or some more unusual, but still natural, explanation. Its silence and lack of conventional activity set off a wave of speculation, but no evidence pointed to anything beyond exotic, but natural, origins. Borisov, discovered in 2019, appeared more like a classic comet. Its outgassing and structure echoed familiar blueprints from solar system study, yet its composition was chemically distinct enough to confirm its interstellar past. 3I Atlas now joins this rare group, standing out for its sustained, organized heat pattern and combination of volatile molecules. With each object recorded, our understanding of interstellar visitors grows, often in ways that complicate rather than simplify the questions we ask. A measured approach. The investigation of 3I/ATLAS is ongoing. Nicholas to the science, there is widespread collaboration among professional and amateur astronomers alike. As the comet draws closer to the Sun, telescopes worldwide are being coordinated to record its changing features, with the aim of capturing every molecule released and every shift in its thermal behavior. There remains a great deal unknown about the processes at work inside the comet's core. It is possible, if not probable, that as 3I/ATLAS nears the Sun, the nature of its thermal signature will change. The pulse could intensify, diminish, or transform, perhaps exposing the cause as a natural result of seasonal heating, structural collapse, or volatile release. At this stage, the responsible scientific position is one of careful curiosity. The enduring mystery draws attention, but the lack of direct evidence for any extraordinary cause keeps theories squarely within the bounds of natural physics and chemistry. No shapes or signals suggesting technology, no deviation from gravitational models, and no risk to Earth have been found. The path ahead. To decipher 3I/ATLAS's core secrets will require more time, closer observation, and possibly the development of new theories or technologies. Scientists speculate about what future missions might become possible. Could we intercept another interstellar object? Perhaps even return samples to Earth for direct analysis? The technological hurdles are immense. The current discoveries, however, are already informing the design of future astronomical tools. Cryogenic samplers, improved spectrographs, and coordinated alert systems are all under discussion. Each new piece of data must be weighed carefully, contextualized within the broader framework of planetary and interstellar science. The process is, by necessity, one of incremental progress, punctuated by the occasional leap afforded by unique observations like 3I/ATLAS. Resolution: mystery within limits. The presence of a rhythmic pulse in the thermal maps of 3I/ATLAS, captured meticulously by James Webb, represents a new chapter in our efforts to understand both the nature of interstellar comets and the range of mechanisms that shape objects beyond our solar system. The origin of the pulse remains unexplained, but evidence for extraordinary claims, such as life or technology, is not present. What endures is a sense of cosmic perspective. These discoveries remind us that the universe is not only stranger than we imagine, but may be stranger than we can imagine. 3I/ATLAS teaches humility, inspiring us to peer closer at data and question what we thought we knew about the boundaries between the known and the unknown. As astronomers continue to track the comet's journey around the Sun and out again into interstellar night, they wait for hints within each new data stream. Will the pulse persist, change, or vanish? Will the chemistry shift as sunlight strikes deeper into the comet's heart, exposing new layers or driving yet unpredictable reactions? Every answer leads to new questions, every unexplained observation to sharpened curiosity. In the quiet aftermath of fevered debate, the lesson is one of patience and careful stewardship of evidence. The broader universe continues to offer up immense, uncharted challenges. Each object, like 3I/ATLAS, offers a snapshot, a moment to reflect on how far we have come as a scientific species and how much remains before us to learn. Looking to the future. Whatever becomes of the pulse at the center of 3I/ATLAS, whether routine, remarkable, or something entirely new, it stands as a testament to how the universe can surprise, even in places we long considered well understood. Scientists and the public alike are reminded that the search for life, for new chemistry, for meaning in the depths of space is built not only on imagination, but on a foundation of rigor, repeatability, and restraint. New instruments promised by future space agencies and missions may one day reveal the true nature of phenomena like those seen within 3I/ATLAS. Until then, each observation accumulates. Each interstellar visitor passes, leaving behind the imprint of new mystery. As we look skyward, the message is clear. The universe is not finished with its surprises, and its oldest travelers still have tales to tell, if only we look, listen, and wait with open, critical minds. The mystery at the core of 3I/ATLAS, its rhythmic heat, its revealed chemistry, its improbable origin, remains open. Whatever the final answer, it will move us forward on the long journey toward understanding not only the cosmos around us, but the foundations of the planets, comets, and even life itself. And as 3I/ATLAS races back toward the black, carrying the unanswered questions away on its tail, humanity is left with renewed awe, a challenge to our best scientific minds, and the quiet promise that the cosmos still holds secrets worthy of pursuit.